So I welcome you all members for design of experiments, basic fundamentals regarding today's session. So this is just an introduction orientation about the course design of experiments. So the same session will be continued for next parallel meetings every day. Now we will get into the topic objectives. So design of experiment is a course which is quite common for all researchers belonging to different engineering domain. The people who pursue PhD already, the persons who have involved during their PhD work, they might have used various tools and methodologies applicable to design of experiments in order to optimize their results during the time of research work. So now today we are going to see the basic outline about the design of experiments. In connection to that, in the next subsequent meeting, we will be knowing about each and every tools and methodologies applied in design of experiment subject up to certain extent. Now let us discuss the session objectives. The main primary motto of DOE is to systematically organize the data which has been collected and gathered, perform the experiments through conducting and analyze the results from the experiments and find out what are all the factors which strongly influence the outcome of the experiment. So this is the first and foremost thing every researcher will be doing. Next one, DOE tries to identify the cause and effect relationship between multiple factors for given experiments that is applicable to, and based on that they will try to make a data driven decision making. So what do you mean by DOE exactly in nutshell? So DOE is considered to be a systematic method which tries to support scientists and engineers to study the relationship between multiple input variables and key output variables. So there would be two dependent input variable and that will influence the response variable, that is the output variable, that we are going to find out through experimentation. So it is a well-structured approach for collecting the data and making so many research and discoveries on that. When under what situation the researcher supposed to use design of experiments? Say you want to find out whether the factor, say a group of factor which has significant difference or not. So in that case, DOE is used. Say two or more than two factors you are going to perform an experimental design. So for that DOE is used. Measuring the interaction between multiple factors to predict the output response variable. In that case also, DOE is more suited. Then to model the real-time behavior with respect to your output response as a function of several factors. So these are the possible cases for using DOE in real time. Why using design of experiments? So using this, we can able to drive more knowledge about the cause and effect between various factors chosen by the researcher to conduct the experiment. And also we can do the experiment by considering all the factors combined at the same time. And that support us to enable the combined effect of factors based on the output results obtained through the experimentation. Say, let us take a simple example. So just now, so far we have seen about the basic theoretical importance. Now we will go with some basic examples. Imagine a situation that dy does not exist. How you are going to statistically infer your data? What classical methods which has been used in the earlier in olden days? Trial and error method, one factor at a time method. Let us take few simple examples in connection to the definition. What is trial and error method? Testing different settings of two factors and see what the output result is. Say you want to optimize the temperature and time in order to maximize the output yield of the process through experiments. Say you take metal heat treatment process, aniline, take time and temperature as one of the input factor. Output is nothing but how you are going to maximize the yield of the property of the material through experimentation. So this is the data. From this data, what we try to infer. So the experiment conducted for 6 times at different temperature and different time settings. So for each set of experimentation, various yield percentage of final value has been given. From this, we want to find out the best combination of value. Say from here, we can able to identify that trial number 5 that gives the best value, optimum value. For a given temperature, 100 degrees centigrade, 12 minutes time period. So we can able to obtain the output yield of particular heat treatment process, 87.75% efficiency. So this is what the trial and error, the classical method says, but it is not most efficient one. When you go for multiple factors, it is very time consuming, inefficient and unstructured. We will not be able to find out the optimum set of condition across two factors or more than that. Next one factor at a time method. Change the value of one factor and try to measure and repeat the same process with another factor. Let us take the same example for this method also. Optimizing the temperature and time and find out the maximum yield. So from this graph, we want to optimize the temperature by finding out what is the maximum yield percentage from the heat treatment temperature level. Same example, metallurgy, heat treatment furnace operations we can take. So the furnace temperatures ranges from 40 to 130 degrees Celsius. And these are the output response measured in efficiency. So here the most optimum value is 90 degrees Celsius. For 90 degrees Celsius, the maximum yield is considered to be 80%. So this is the data read from the graph. Next one, change the value, optimize the time and find out the maximum yield. Earlier example was changing the temperature, what is the maximum yield. Next example, interchange the time and find out what is the maximum output yield. So here the time value for the heat treatment process of a metal ranges from 5 hours to 25 hours, and the yield percentage 72.5% to 92.5%. So out of this, I can find out the optimum yield as 86.5% for 12 hours of time. So at this time period, I'm getting the maximum yield percentage by heat treating the metal at so much hours inside the furnace. So by doing the same for many number of trials, say 14 trials, so it is observed to be 86.7%, the maximum percentage of the efficiency. So how we are getting under what input circumstances? When the temperature is 90 degree, time is said to be at 12 hours. So we are able to get this percentage of yield. And here there are one more problem in one factor at a time. What if the optimal temperature and time settings look in this format? See here, the optimal temperature in red color, that is the optimum yield shown in red color, is 92.5 and 86.5, which is the most optimum value. So it is very fuzzy, more confusing. So unluckily, we could not able to find out the optimum set of conditions when we are going for two or more factors using one factor at a time or trial and error. So it is advisable to use design of experiments to optimize two or more values. So here, for each input, determine the level of determine two levels, higher level and lower level of achievement. Say -1 and +1. In some cases, the extreme levels may be beyond what is currently in use. These extreme levels selected should be more realistic. Say for an example, two different readings of temperature. One is said to be at the lower level, the other one is said to be at the higher level. 100 and 200 degrees Celsius. 100 represents -1, lower level of achievement of temperature. +1 represents a higher level achievement of temperature, 200 degrees Celsius. Same thing, pressure also, we can able to vary the significance level between the lower and higher level limit, say 50 pounds per square inch and 100 pounds per square inch. See, when we are setting two different levels of achievement, we can able to find out the degree of variation between the each level and also the factors, temperature and pressure, and how this temperature and pressure going to influence the final output response variable through experimentation. So this is the experiment conducted for various temperature and pressure. From that, we are going to find out the strength of the material, optimal strength of the material measured in pounds. So totally two factors are taken. One output response variable, that is strength. Pressure and temperature are the input variable. See, now we have to find out the interaction between temperature and pressure by optimizing the strength of the final material. So how do you calculate conventionally, manually? Calculate the interaction effect by averaging the data to be collected at the lower level and subtract the average of data collected at the higher level. So this is the formula for both the temperature and pressure. In terms of strength, we have to calculate. And this is the results that has been displayed here. Combined effect of temperature on strength, combined effect of pressure on strength. So this can be diagrammatically represented by means of a 3D bar chart. So from this data, we can able to take a reliable decision how the material, the strength property can be optimized with reference to temperature and pressure based on the mechanical heat treatment process. So from this introductory lecture, I want to conclude regarding the today's session. A DOE is a well-designed experiment that allows real valid information with proper analysis of information, leading to a more reliable statistical inferences for better decision making. DOE is a most essential important tool for engineers, which leads to have systematically investigation of various process by further optimization in more real time and practical sense to identify the system behavior. It helps to identify the most important variable and their levels of optimism, leading to improved quality, reduced product cost, and quickly delivering the product to market at a short span of time. This is how the DOE can be used for engineering professionals in practical scenario. Now, with this new information, I thank you once again, all of you. The next session likely to be continued tomorrow under the same domain, design of experiments. Once again, thank you all.